right, so our second problem for graphing rationals, we have negative 4x squared plus 4x plus 120 over x squared minus 4x minus 12. So let's go ahead and factor. Oops. So on top, we do have a GCF on this one, and it's negative 4. Okay, remember, if the first term is negative, you always pull out a negative. Okay, if the first term is negative, pull out the negative. Okay, that's important to know, just in general for no reason. Make sure you know that. Okay, so we pull negative 4 out. I'm left with x squared minus x minus 120 divided by negative 4 is negative 30. Okay, and on the bottom it doesn't have a GCF, so I'm just going to bring it over. Okay. So up top we have our negative 4. Now we need two numbers that multiply to negative 30 and add up to negative 1. So that would be x, or negative 6 and 5. Okay, and then on the bottom we need to multiply to negative 12, add up to negative 4. So that is going to be negative 6 and 2. Okay, now again, before we cancel anything out, we're checking our domain. So I have negative infinity, 2, and again with domain we're just looking at our denominator here. Okay, so that's going to give me 6 and negative 2, so we can't have negative 2, and then negative 2 until 6, skip over 6, and up to infinity. Okay, now let's find our reduced form. Cancel those out. So we have negative 4 times x plus 5 over x plus 2. And you can just leave it like that. Don't multiply the 4 back in. Okay, now let's check for wholes. So we did cancel something out. We canceled out our x minus 6. So we know we're going to have a whole at 6. And then I'm going to plug that into my reduced form. So negative 4 times 6 plus 5 over 6 plus 2. Okay, and then you can just put that in the calculator or you can do it yourself, and that gets negative 5.5. So our whole is at 6, negative 5.5. Okay, vertical asymptote, we're looking at the denominator. So x plus 2 equals 0. Solve for x, we get negative 2. Okay, horizontal asymptote, we're looking at our degrees on top and bottom. Okay, on the top, our leading term is going to end up being negative 4x, right? If you multiplied that back out, on the bottom it's going to be x. Okay, our degrees on the x's are the same, so those are going to cancel out, and I'm just left with negative 4. So we have y equals negative 4 for our horizontal asymptote. Okay, x-intercepts. Now we need to look at our numerator. So numerator, we have negative 4 equals 0. That's not going to tell us anything. And then x plus 5 equals 0, which will give us negative 5. Okay, and then our y-intercept, we plug 0 in for x. So I have negative 4 times 0 plus 5 over 0 plus 2. Okay, again, do that, type in your calculator. Either way, you get negative 10. So our y-intercept is at 0, negative 10. Okay, I'm going to point out one more time, these are equations, and these are points. Okay, make sure you keep them that way. Okay, last here is our end behavior. It's always the horizontal asymptote, so that's going to be negative 4 and negative 4. Okay, now let's draw our graph. So We have a hole at 6, negative 5.5. So I'm going to go over 6, down 5.5. 1, 2, 3, 4, 5. So about right here is our hole. Okay, vertical asymptote. See, I'm going to get another color. Let's get a lighter color actually. So vertical asymptote is at negative 2. Okay, horizontal asymptote is at negative 4. Okay, and then we have our x and y intercept. So x is negative 5 and y is negative 10. Okay, so all you need to do is just plot basically everything that we found. Okay, all this stuff. Okay, and then this one's another nice one where we can kind of just tell what our graph's going to look like, right? On the right side, we have this y-intercept and this hole, so we can kind of tell our graph's going to do that. And then on the left side, we have that x-intercept, so we know it's going to be above the horizontal asymptote, and it's going to look something like that. And again, you don't have to be like super accurate. As long as you have all these things graphed, that is good enough. Okay, that's the second problem.